The universe is really, really big. How big exactly? Well, we don't know. There are three main theories about the universe: the eternal inflation theory, steady state theory, and the oscillating universe theory. The eternal inflation theory, considered by Alan Guth, Andre Linde, Paul Steinhardt, and Andy Albrecht in 1980, states that the universe is expanding extremely rapidly after the Big Bang explosion. What is the Big Bang? What is the Big Bang? What is the Big Bang? Well, we'll get there in a second. The explosion was so fast. It increased the linear size of the universe by 10 to the power of 26. To explain how big that number is, I wrote the entire number out. Why? Because I'm crazy. The second theory is a steady state theory. It says that the universe is always expanding, but it maintains a constant average density. It states that the universe is expanding, but always maintains a It states that the universe is constantly expanding, but maintains a constant. It states that the universe is expanding, but maintains a constant average density. This means at the same rate that stars and galaxies are born. This means at the same rate that stars and galaxies are made. This means at the same rate that stars and galaxies are made, others diminish. Galaxies, if you don't already know, is a massive collection of dust, gas, and millions or even billions of stars. The steady state theory, theorized by Erman Bondi, Thomas Gold, and Fred Hoyle in 1948, so that would, if we do live in a steady state universe, that would mean there would be no beginning or end to time. So that would basically mean that the Big Bang never actually happened. The final theory is the oscillating universe theory, considered by Albert Einstein himself in 1930. The oscillating universe theory is believed to be true by many cosmologists. It determines that the universe is infinite or indefinite with self-sustaining cycles, but the observable universe, the part of the universe that we can see visually from Earth, is only a tiny fraction on how big that the universe actually is. Or at least in theory it is. If the Big Bang really was the creation of our universe, the Big Bang happened 13.82 billion years ago, and that's how old our universe is. The first 3 minutes of the Big Bang was a huge mess of things colliding, forming, and the extreme rapid expansion of our universe. Right after the Big Bang, we would see a 10 billion degree mass of neutrinos, positrons, electrons, anti-electrons or positrons, photons, and neutrinos. 10 seconds after the Big Bang is the origin of fluctuations. 100 seconds after the Big Bang, and particles form and simple atomic nuclei formed in the first 3 minutes of the Big Bang. 380,000 years after the Big Bang, the cosmic microwave background or electromagnetic radiation is released. After the explosion of the Big Bang, the universe was made of After the explosion of the Big Bang, the universe was made up of After the explosion of the Big Bang, the universe was made up of radiation and subatomic particles. After the explosion of the Big Bang, the universe was made up of radiation and subatomic particles. NASA has multiple missions to study the cosmic radiation. NASA has multiple missions to study the cosmic radiation. We even have pictures dating back to 400,000 years after the Big Bang explosion happened. In 1922, they launched the Cosmic Background Explorer, or the COBE. This had mapped the primordial hot and cold spots in the cosmic background radiation. This had mapped the primordial hot and cold spots in the cosmic radiation This has mapped the primordial hot and cold spots in the cosmic background radiation. These spots are related to the gravitational field in the early universe and forming of giant clusters of galaxies that stretch hundreds of millions of light years across the universe. As I said earlier, the universe is 13.8 billion years old. As I said earlier, the universe is 13.82 billion years old. The Planck mission has made the most accurate map from the oldest light of the cosmic microwave background. Patterns of the light show events that happened just seconds after the Big Bang. So scientists studying these patterns can learn about the origins, the fate, and other things in the universe. Patterns of the map show events that happened just seconds after the Big Bang. So scientists studying this map, patterns of this map shows events that happened just seconds after the Big Bang. So scientists studying these maps can learn about the origins, the fates, or whatever else is in our universe. The parallel dimensions theory of quantum mechanics was created 50 years ago by Hugh Everett. If quantum mechanics were applied to the whole universe, then it should if quantum mechanics was applied to the whole universe, it should exist everywhere. There would be a multiverse of parallel universes, one for every possibility. In just one dimension, it would be a singularity, or the state of being one or singular. But in this idea, there would be millions, if not billions, of dimensions. Earlier I mentioned Sir Fred Hoyle when I was talking about the steady state theory. Hoyle was born in northern England in 1915. He went to the University of Cambridge and studied math and theoretical physics. He helped found the Anglo-Australian telescope, and he helped co-develop the theory of evolution in He helped found the Anglo-Australian telescope, and he helped co-develop the theory of evolution of red stars with Martin Schwarzschild. Hoyle made a mathematical theory of relativity, and it featured the creation of matter. A couple of high technology telescopes that we have up in space a couple high technology telescopes that we have right now are the Hubble Space Telescope, Herschel Space Telescope, and Spitzer Space Telescope, and so on and so forth. And that's just to name a few. We have almost 200 others up in space. But we have sent some spacecrafts up into space, and they were never planned on and they were never supposed to come back. But we have, however, sent spacecrafts up into space, and they were planned to never come back. A good example of this is Voyager 1. It was sent out to space to retrieve and send data or information back to Earth. However, sometime in its journey, it took this picture. It was sent out to space to send and retrieve information back to Earth. It was sent out into space to send and retrieve information to send it back into Earth. But sometime on its mission, it turned its camera around and took this picture. This picture may not look so special at first glance, but to take into context how important this picture is, Carl Sagan once said one of the most amazing things ever said in human history, and it was about this photo. He said, "If you look at it, you see a dot. That's here. That's home. That's us. On it, everyone you've ever heard of. Every human being." He said, "If you look at it, you see a dot. That's here. That's home. That's us. On it, everyone you've ever heard of. Every human being who's ever lived out their lives. The aggregate of all of our joys and sufferings. Thousands of confident religions, ideologies, and economic doctrines. Every hunter and every forager, every hero and every coward, every creator and destroyer of civilization, every creator and destroyer of civilizations, every king and every peasant, every young couple in love, every hopeful child, every mother and father, every inventor and explorer, every teacher of morals and every corrupt politician, every superstar, every supreme leader, every saint and sinner of the history of our species lived there, on a mote of dust suspended in a sunbeam. Every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam." And that's why this picture, in my opinion, is one of the most amazing ever took in human history. But with that being said, there are three possible fates of our universe. The first is the Big Crunch. In this fate, the universe slowly stops expanding and just eternally stops. In this fate, the universe slowly slows down, expand. In this fate, the universe slowly stops and expand. In this fate, the universe slowly stops expanding and eventually just stops. The Big Crunch will take place when the Big Crunch takes place. Our universe will start to when the Big Crunch takes place, our universe will start to contract. The next fate says that the universe will never stop expanding. It just keeps going and going on forever and ever, and it just never stops. The last idea is balanced between the previous two fates. It states that the universe slows down very, very slowly, but it never comes to a complete stop. It expands forever and ever, but it never really ends. It just continues very slowly. And that were the theories of the origin of the universe. Thank you for watching. Peace.